Trying to innovate it's not easy. Finding a place where you can do it, it's even worse. I've been lucky finding my school, the Erasmus de Rotterdam, that allowed me to experiment on different platforms, use different technologies to achieve the goals that I set myself. Our growth has allowed us to interiorize all that we have done during these years. We firmly think that robotics has to develop in schools since it allows us, and we experimented, to learn more compared to the classic student-teacher learning method. Robotics allows students to try with their hands the technologies that are being used, and this prepares them to a work environment. This process is not easy but can be made easier by choosing the right company to work with, as the one in this contest. For this reason, we are in the XIL University program. The whole program of technology is highly interesting. We used a similar approach in the past 3 years, virtualizing a microblaze in all our project, eliminating the cost of additional hardware. Modifying the processor was easy, but having a Cortex embedded in this component, or in this case 2 Cortex, will be very useful. Technology is going in the right direction to help us develop faster and better. We are always aware of what happens in other places. We always try new components while not getting too far from tradition. We are porting all our software to C++. It is clear that classes are a lot more suitable and easy to work with than structure of C. We want to create classes that have as only initialization input the base address of the peripheral. In this way, the software platform will be fully transportable across multiple machines. We also need to point out that all the XIL tools have been stable, fast, useful, and without them, these kind of ideas wouldn't even be possible. Connectivity and expansion is also a must, seeing what is happening across the world. The Internet of Things, or even the Internet of Everything, as called in Cisco. We wanted our thing to be connected to the outer world, so we decided to embed Bluetooth connectivity, and it will be possible to expand it with many protocols that we break out, like multiple E2C, multiple SPI, CAN bus, and even parallel bus. This protocol will allow us to embed Wi-Fi in the near future. In order to achieve these goals, our past experiences have been really useful. A difficult competition like Robotic allows us to test on a shared field the huge number of IP, the designs, the software strategies that we applied in many past years. We developed many integrated packages. Some of them are simple readers for the infrared sensor, for example, or the light frequency sensors. Others are more complicated and goes beyond the simple read and update of them. We developed an IP that manages 8 IR sensors and clean reads. Banding to the same kinds of sensors is useful to remove noise and get much stable reads. We also developed an ultrasonic control, as we call it. It bounds 3 or 4 ultrasonic sensors and gives us nicer results. As with other hardware, we are developing complex systems that are easy to use. We are near to complete the final version of the motor control IP that it will integrate a PID and an encoder to read for feedback. With earlier version of this IP, we achieved sub-millimeter precision on common motors. This platform is totally open and will be available on GitHub. It's already free to public, and we are excited to see how other schools will improve this large and easy to use system. We released this project as whole package and many single package because a key feature of our system is that users can remove packages, softwares, libraries to develop their own while having our stable and secure core. If, for example, another school wants to build a new sensor and integrate it in our project, it can do it, integrating all the packages that the school wants to use. This platform can be used from a user in a totally closed way, as Arduino does with the libraries, or removing IP, allowing integrating custom solutions. Developing with this in mind is not easy, but we truly believe this. This idea was first developed on the microblaze processor, and much of the software has been ported from that platform. During the porting to Z-board, we have one major problem. Being the microblaze little engine and ARM big engine, we have to rewrote almost all drivers, and now they can be taken on the ARM platform. It was complicated, but we are glad we did it, because now our drivers can work on all existing processors. We planned a porting to the Zybo board since the platform is more economic and therefore more accessible to school, and smaller, more versatile in the case of embedding. We would like to thank once again XIL for giving us this board and allow us to be able to experiment once again. Once we implemented all the drivers, all the software and all the programmable logic, we wanted to make available to the public some utilities that would allow data visualization since the user might not know how to use our machine. We developed the visualizer program for the IR bar not filtered and filtered of course, the ultrasonic sensors and control IP, and the motors with all the data of the algorithm we built and speed regulation. With the new motor algorithm that uses complex mathematics will be useful to represent parabolas and line across a virtual X and Y plane. We will include it shortly in our repository. Another important thing in the development of this project was to include a lot of software from which it was possible to start. You have seen that Arduino has extremely rich libraries of software, and this makes it easier for the inexperienced user to use the platform. We decided for the same reason to create many libraries and many ready-to-use and ready-to-include software. We are releasing an obstacle avoider, a filtering algorithm for sensors, and an example of communication with computer to serial ports. Many other demos and examples are currently in the development stage and will be included shortly. This robot is intended for use in labs, in schools, from persons that want to learn on the old programmable platform, and we created it as a rover because it is a difficult platform to design properly, but really easy to use. This will allow the user to think more at the software and logic rather than the hardware problems in the machine. Thinking at this, we wrote a lot of documentation and dedicated a lot of time to the writing of the report. We strongly believe that everything made for even a small public should be well documented to allow fast development. We think very much at how we write our software because we know that it will be used from many people and also from us. We hand down robot generation to generation, class to class, and we are always sure that our software will not disappoint us. Some of the software used in this contest has been created more than 2 years ago and still works perfectly, even with different devices and sensors. We make small changes to adapt it, but we have no reason to rewrite it since it works, and it works well. The all programmable technology is not only useful for its richness, but also because we can reconfigure the machine as we need, and this for learning and teaching it's very helpful. Our machine is a general purpose machine and can be used in many other areas that are not the schools. We have used it to solve labyrinth and recognize victim, as the frontal ultrasound sensors are useful for this purpose. We tested the temperature sensor that will be useful to recognize human pairs or heat in general. Thanks for watching this video. We hope to continue to develop with science and digital.